All right, thank you very much, Matt. Yeah, thank you very much, everyone, for joining our demo session today. Before I will show you the application as it currently exists, there's a number of things I'd like to highlight to you first so that it's clear to everyone what we are looking at here. Now, after we would install the application, there's the first thing we would do is run the analysis on the system we're trying to profile. In general, we look at about 80% of your largest memory, just because that is probably the area where you would find the most interesting information that you can actually act on. Once the analysis has run, we present the information, and actually this automatically works, of course. We present the information from the analysis in this application. Now, running this application requires no additional software. It's a native UI5 application, SP UI5 application, which, if you have HANA, is already available for you. Now, because this is a demo session, we'll of course be using demo data, so don't pay too much attention to what you're seeing and focus on more on the message that we're trying to share with you here. Now, as Matt already mentioned earlier on in the presentation, is that there is two things that we are focusing on here. One is your data footprint, your data aging, so to say. How old is your data? What years is it sitting in? And the other part is what part of that information that you have in your system is actually used, because the combination of the two makes it interesting for you to have a look at what can we potentially move to a different type of storage, to a cheaper solution, so to speak. Now, these two pillars will come back in all the things I'll show you, and we'll start actually looking at the platform as a whole. Now, once we run the analysis on the system, we know what your total memory size is within your system. So in this case, it's about 469 gigabytes, about 470 gigabytes actually. So that's the total memory that's within your system. Now, the second part is where we really will be looking into the estimated warm potential and the total profile. These are two separate measures for the basic reason, starting off with the total profile, is that not all data will, of course, sit in memory. So we will look at your data, see what you have, and we will profile what we can. Some of the data that you'll have in memory won't have dates, won't have year fields, won't have anything that Oxygen will be able to determine the age, so to speak, of your data on. So that is basically the difference that you'll see between the total memory and what we consider to be the total memory profiled. Now, the total memory profiled in this case is the 254 gigabytes. And of that 254 gigabytes, there is actually 141 that we were actually able to do the estimated warm potential for. Now, the difference again there is that you might have tables in memory for which there is no date column. You might have tables in memory for which the date columns are not in memory, right? So there's, again, a little bit of a difference there. But once we run all the analysis, we basically come up to, for the entire system, we see here that we have 141 gigabytes estimated warm potential. Now, what do we mean by that? We basically say we have 141 gigabytes of data that is aged from before 2018. And we say 2018 because we look at the last 2 full years plus whatever the current year is. We consider to be relevant current data, and everything before that we consider to be the estimated warm potential. Now, we of course realize that's varies per business case, per system, but this is the starting point. It at least will give you a point to look into as to where's the data sitting. Now, the next thing is we're starting to look at a little bit more deeper. How do we split that up? Because it's good to know overall over your system, how much do you have, but you want to look more detailed. You want to go to somewhere that you can actually act on. So the first next thing that will show the largest business areas. So what do the tables and columns that are in memory, what business area do they belong to? That's completely configurable, but in our example, we see that the majority of it is actually sitting in the shared business area, which is quite generic, but we'll again go into that a little bit more detail in a second. After that, we come up to the things that is actually going to give you more information about what is sitting where and how much is used. So you see the data aging, that of that data that we profiled, we have 56% sitting in the before 2018 bucket, which is basically everything we consider to be the warm potential again. The rest of the information is sitting in the more recent years, which we assume that is more relevant and will be queried on more by your users. Which then brings us to the next part where we talk about the data usage, which is actually looking at the system and how much of the information in which years is being queried. And indeed, you see here that even though we have 56% sitting in before 2018 buckets, and those are all the years before that, so it could be 2010, it could be 2012, but only 15% of all your queries against that are sitting in that range. The vast majority, 25% into over 2018 data, 48% for the more recent 2019, and then maybe only 12 because people are looking at the last full year. Again, this is just demo data, but you get to the point, right? What the message that I'm trying to share. Now, the final piece of information that we're also trying to show here is to what extent is this data used either for reporting or either for staging. So this is a feature that's still in the works, but we wanted to give you an idea of this already because it can be quite powerful. Of course, when data is sitting in reporting, it's much more important for the end users than data sitting in staging. You would deal with it in a different way, and that's why we feel it's an important feature to have. Now, keep in mind, as I mentioned, all these things will come back when we look to the next level. So we were now looking on the platform. If I go one back and go into the business areas, we will be presented with the exact same information again. We see the total memory by business area. We see the estimated warm potential as part of the total data that we were able to profile, the data aging, as well as the data usage. Now, as I mentioned, you want to make this actionable. So we want to go deeper into this, and let's have a look at the shared business area, because this is where the majority of the estimated warm potential sits. All right, again, once you go in here, you'll be presented with some of the same information you already saw earlier, just for the user to keep it clear what he or she is looking at. And we again start off with those two important measures that we were referring to, the data aging, how old is the data that we profiled for this business area, and to what extent is it used. And here you also see very clear that picture that Matt also showed earlier in the presentation, is that older data is in general less used. So you probably want to have a look and see what you can safely move to a different type of storage to either make space for a new project or perhaps to save you some money. Now, there's a number of other things that we show. We show you the data purpose. In this case, it's not filled. But we also show you row and column storage. Again, this is something that we feel can be interesting to look at, might not always be. But the reason why we do highlight it is that in general, most things in HANA will be column store. But it is interesting because if you would, for example, see a lot of row store tables per definition are always completely in memory. So if you have a lot of tables that perhaps there for good reason, but perhaps are there because it was not correctly developed, some of your solutions, you might be using a lot more memory than you would actually be needing. So also that is something that we show you. Now, when I talk about actionability, this is what I really was referring to. Here you get an overview of your tables in descending order by the warm potential. So again, right, the estimated gigabytes that we consider to be 2 years and older that you might want to look at having to move off by table. So you can really see this table sits in this schema, has 14 gigs of warm potential. Again, and you are presented with data aging and data usage. Now, again, you can go in here and really see, okay, what is the data footprint of this table? So you see that there is data all the way back from 2007, 8, 9, 10, all the way to the current years. But if you look at the actual data usage, so the querying that's done by users to fetch the data, that's really just on the last 2 years, a little bit on the current year, but the vast majority is on the year 2019. That means that all of this data sitting there, it's using up space, and it might be there still for a good reason, but this for you should or could be a trigger to say, well, this might be indeed a table that we want to look at and see whether we can offload some of the information that we are that we have in this table, because it's sitting there, but apparently it's not being used. Now we have that same information again, a little bit further down, where we show by years where the vast majority of the usages is sitting, but also what the biggest years are. Now, currently, this is based on the date field in the COOP table that we think that we use to profile it by year. But of course, some tables have more date fields, so we will be extending this, for example, also with the other date fields. So you can see, well, if I look at it by creation date, it might be this year's distribution, but if I look at it by posting date, it might be something else. I want to close off the demo by going all the way back and going to the memory usage history and give you this final picture, which shows you the trend of how the hot memory and warm potential developed itself in your system, or in this case in the data system, in the demo system. You can see that data goes up over time and then again goes down once you actually act on the warm potential that you have. Now, there's a couple of other measures on the screen here. The one that I do want to mention, and then I'll give the word back to Matt, is the SAP suggested max memory, which is the 50% limit, where you basically want to stay below so that you can keep the rest of your system available for all the calculation that it needs to run. That's all I wanted to share, and I'll give the word back to you, Matt.